Hey guys, welcome back. We are right now today with a very important topic. I'm laughing because I know this thing that many of you were already saying me to record this lecture, and I'm really very sorry that I'm late on this. But please don't say anything because still your exams have a few days. Okay, so right now we are going to start a very important topic, and guys, on the serious notes, now I'm going to start ionic equation. What is an ionic equation? How to write an ionic equation? Different examples of ionic equations, all will be in this lecture, inshallah. So let's start. First of all, what is an ionic equation? Let me tell it to you very clearly. An ionic equation is that in which certain ions are involved along with the non-ionic, you may say, components in it. We are going to consider this type of the equations, and then when we will be able to write such type of the equations, then you people can get the better idea. Okay, so how to write the ionic equation? There are certain rules which you should have clearly in your mind. Number one is to write down the balanced chemical equation. So what is a balanced chemical equation and how to write a balanced chemical equation? This is very important. So students have practiced the balanced equations with me when they were practicing periodic table chapter and when they were learning the chapter of acid, bases, and salts. I will definitely try to write down certain other examples of the chemical equation, how to make the balanced chemical equation. But before moving ahead, I would like to give you a simple thing that balanced chemical equation is basically telling you that we have to keep the number of times one substance and the reactants and products equal to each other. Balanced chemical equation is basically developing a balanced relationship between reactants and products. So what are the reactants? Those which are written before arrow. And what are the products? Those which are written after arrow. And we have to make a balanced chemical equation by writing the numbers 2, 3, 4, or sometimes no number. When there is no number, it is considered as 1, or sometimes no number, so that we may be able to make the things equal to each other in an equation. Okay, so let me inform you what is the step number one. It is to write down the balanced chemical equation. What is the step number two? Ionic equation can be written for those which are containing at least one water soluble substance. If only water insoluble substance will be involved, then ionic equation is not possible. So it means that ionic equation is possible for those substances which are going to convert themselves into their ions. At least such type of one substance should be present. For example, there is a reaction in which carbon is reacting with oxygen to make carbon dioxide. We are going to consider carbon as insoluble substance, oxygen a gas and insoluble substance, and carbon dioxide a gas and insoluble substance. For such type of the reactions, we cannot write the ionic equation. Okay, so it means that for an ionic equation, one should know the solubility of the substances as well. So here I have given you another equation. So it is sulfur burning in the presence of oxygen, burning in the presence of air, roasting in the presence of air, and it is giving you sulfur dioxide. As there is no aqueous substance, so we are not going to write the ionic equation for this. Now, there is a term aqueous. Yes, I have already explained these terms to you in the chapter of kinetic particle theory, but I'm going to tell you some details to you again. So there are basically four states of matter. What are the states of matter? That in which state they are existing. Okay, in which state a matter is existing is called as state of matter. Okay, so there are basically four states of matter. One of the state of the matter is solid, the second is liquid, third is gas, and the fourth is aqueous. Aqueous will be represented with the symbol AQ. What is an aqueous substance? It is a substance which is being dissolved in water, and it is a substance in which the substance converts itself into its components, and these components are surrounded by water molecules. So this is called an aqueous substance. Okay, so right now in this case, we are writing that we cannot write the ionic equation. And why it is so? It has been already explained that as in this case, basically the partners are not water soluble. That's why we are not going to write down the ionic equation for this. If we are talking about number 3 point, we have to convert the water soluble substances into their ions. So we should know this thing, that what are the water soluble substances and what are the water insoluble substances. We have to convert the water soluble substances into their components. Okay. And then we have to find out the spectator ion. Yes, I know this thing, that it is a new term, and I'm going to explain the spectator ions to you in detail. Before moving ahead, what are the spectator ions? Towards the concept of spectator ion, one should know only the rule that we have to cancel the spectator ions very clearly. Okay, now what are the spectator ions and how to develop the ionic equation? Move on to the next one. Here I have written spectator ions are those ions which are in the ionic form on both sides of the equation and are cancelled on both sides of the equation. So it means that first of all we have to write a balanced chemical equation. We have to select that which are the which components are soluble. Then we have to convert them into their ions. Those which are in the ionic state before reaction and after reaction, those are considered as the spectator ions. We are going to cancel the spectator ions, and then we are going to write down the final equation. Okay, so we can say this thing that spectator ions are those ions which are in the ionic form on both sides of the equation. You may say before reaction and after reaction, and are cancelled on both sides of the equation. They have no role for designing of the ionic equation, you may say. Okay, then number 4, cancel the spectator ions on both sides of the equation and write down the remaining net equation. The resultant equation, the equation which is left after cancellation of the spectator ions, is called as the remaining equation, net equation, resultant equation, total equation, sum up equation. All these names can be assigned to the final equation. Okay, then so water and gases are considered as insoluble in water. So for example, if you are adding 1 glass of water into 1 jug of water, 1 jug of water into 1 tub of water, will there be any chemical reaction? No, there will be no chemical reaction. So we can say this thing, that all these are considered as insoluble. Okay, all of these are considered as insoluble. So here, before moving ahead, I would like to inform you that in such type of the reactions, one should know this thing very clearly, that which substances are soluble and which substances are considered as insoluble. Okay, let's consider the first example. Guys, before moving towards the examples, I would like to ask you very clearly that one should know what is the solubility of the substances. So it is advised to all of you that you people are going to memorize the solubility table. Hence, you people are going to look into the things, that what are the substances which are soluble and what are the substances which are insoluble. So for this, I would like to inform you that you are going to keep that information from the solubility of acid, bases, and salts, and then we can learn this thing, that these substances are soluble and these substances are insoluble. For example, we can say that all the compounds of group number 1 are soluble. All the compounds of, you may say, nitrates are soluble without any exception. All the gases will be considered insoluble here. Acids are soluble, and all the sulfates are soluble except for lead, barium, and calcium. All the chlorides are soluble except lead, silver, and mercury. So such type of the concepts should be in your mind. All the carbonates will be considered as insoluble. Okay, let's solve the first one. Okay. So in this example, we are taking the reaction of NaOH and HCl in consideration. What is NaOH? Sodium hydroxide. It is an alkali. It is a base. It is a water-soluble base. That's why we are considering it as an alkali. So it is going to react with an acid. HCl is an acid. It is called as hydrochloric acid or hydrogen chloride. After the reaction, they are making NaCl called sodium chloride and water. We are going to convert NaOH into its components. What are the components of NaOH? It will be Na plus 1 and OH 1 minus. So we should know this thing, that Na plus 1 is having Na plus 1 charge because it is part of group number 1. OH is a radical, it's a polyatomic ion. I have told you about the polyatomic ions in the chapter of ionic bonding. It is having a charge of -1. What about the HCl? It is converting itself into two types of the components. One is H plus 1, the other is Cl1 minus. In case of NaCl, it is converting itself into two types of the components, Na plus 1 and Cl1 minus. We know this thing that H is always having a +1 charge. Cl is a part of group number 7, having a charge of -1. Na is a part of group number 1, it has a +1 charge. Cl is going to have a -1 charge, being a partner of group number 7. Guys, can you look at here right now very clearly that I am writing aqueous, aqueous with all the ions? Oh, right now water is there. Yes, we are going to consider it as liquid. Why? Because just now I have told you that there will be no reaction when water will be added to water. So it is going to convert itself into the liquid state. So here I am going to select the spectator ions. Yes, guys, what are the spectator ions? Na and Cl are considered as spectator ions because they are in the ionic state before reaction and after reaction. So we are cancelling the spectator ions and the remaining equation will be written as it is. It is OH1 minus H plus 1 and H2O. Guys, don't forget to write the state symbols in your ionic equation. This is the ionic equation. You can say this is an equation which is involving ions as well. So it is a molecular equation in which no ions are there. This is called as a molecular equation. And this is the ionic equation in which we have to include the ions of the water soluble substances. Guys, I'm going to give you a key point, a target point, a very important thing, that always, whenever we are writing an ionic equation, we should know this thing, that it is OH1 minus, which is from the base, and it is H plus 1, which is from the acid. They are going to react with each other to make water. So this is the ionic equation for all neutralization reactions. Okay. So whenever there is a neutralization reaction, whenever there is a reaction between an acid and a base, this is the ionic equation for that. Okay. So this you are going to keep in your mind, guys. I have given you only one example. I have a planning to give you further more examples. I have written here for you. I am going to give you all these examples in my next lecture, but right now it is my advice to all of you to keep the solubility table in your mind, to keep the rules for writing ionic equation, and to understand and try to understand again and again that how to write the balanced equation and what is the way to write the ionic equation from this first example. Okay, I would like to explain the next examples in the next lecture, but right now it is an advice to all of you to recall the solubility table and to practice the balanced chemical equation. Okay, all the best to all of you. See you in the next class with the next examples of ionic equations. Thank you very much.